There is an object that could already be moving toward Earth right now, and you would never see it coming. Not because it is far away, because it gives off no light at all. The nearest one we have found sits about 1/560 light-years from here. Close enough, in cosmic terms, to be in our backyard. And astronomers think there are 100 million more hidden across our galaxy that we cannot see at all. So here is the question. This whole video is built around what would actually happen to Earth and to you if one of them came near. The answer is the last thing you will hear, and it is not the answer almost everyone expects. Stay with me, because the most surprising thing about a black hole is not how it kills. It is how wrong our picture of it is. Let me show you, step by step, what really happens as one gets closer, starting with the moment we would notice nothing at all. The first thing to understand is that a black hole is not a cosmic vacuum cleaner. This is the myth almost everyone carries, and it is wrong. A black hole does not roam space hunting for things to swallow. It has gravity. Exactly the same gravity any object with its mass would have. The danger is not that it reaches out for you. The danger is what happens to the space immediately around it. And that single distinction leads to something that sounds impossible. If the sun turned into a black hole tomorrow, same mass, just crushed into a tiny dark sphere, the Earth would not get pulled in. We would keep orbiting, exactly as we do now, along the exact same path, as if nothing had changed. Gravity depends on mass and distance, and neither of those would change. The planet would not fall. It would circle a black hole, calmly, the way it circles the sun today. Hold on to that, because it quietly rewrites everything you're about to hear. The thing we are taught to imagine as an inescapable drain is it's, from a safe distance, just another point of gravity. No greedier than the star it replaced. But to even make a black hole out of a star, the universe has to do something violent first. And understanding that act is the key to understanding everything that follows. A black hole is what a giant star leaves behind when it dies. For its entire life, a star is a war between two forces. Its own crushing gravity pulling inward, and the nuclear fire at its core pushing outward. For millions of years, those two forces hold each other in a perfect, glowing standoff. But the fire needs fuel, and the day the fuel runs out, the outward push vanishes in seconds, and gravity, which never tires, wins all at once. The core collapses. For the biggest stars, nothing in the known universe is strong enough to stop that fall. The matter caves inward past every limit physics has, crushing down and down, until it becomes a region where gravity has effectively sealed itself off from the rest of reality. The star does not explode into a black hole. It falls into one, and the corpse it leaves is so dense that the rules begin to bend around it. So that is what one is, and where it comes from. Now let us go back to the worst day in Earth's history, the day a black hole takes the sun's place, and live through it, because the pull was never the thing that would kill us. The sun crushed into a black hole would be astonishingly small. Our star, the thing more than 1 million Earths could fit inside, would collapse into a sphere you could drive across in under 10 minutes, roughly the size of a small city. All that mass, all that fire, the engine that every living thing on this planet depends on, squeezed into something the width of a town. And the instant it did, the light would stop. 8 minutes later, the time it takes sunlight to reach us, the sky would go dark, and it would never come back. That is the real first threat near a black hole. Not the pull, the dark. And the dark brings the cold. Within days, the surface of the planet would begin to freeze. Within a week or two, the oceans would start sealing over with ice from the top down. Photosynthesis would stop almost immediately. The entire food chain rests on it. Life on the surface would have very little time. The only survivors might be the strange creatures clustered around volcanic vents on the deep ocean floor, who never needed the sun to begin with. So before we go deeper, tell me in the comments where you are watching from. and how long you think your part of the world would last without the sun. The tropics? The coasts? The places near geothermal heat? I want to see who thinks they would hold out longest. Because here is the thing. None of this is the part that should scare you. The real danger only begins when you stop watching from a safe distance and start getting close. So let us do that. Let us stop imagining the black hole far away and start falling toward one. As you approach, the first thing that turns dangerous is something that feels gentle everywhere else: the difference in gravity between your head and your feet. On Earth, your head is pulled very slightly less than your feet because it is very slightly farther from the center. You never notice it. Near a black hole, gravity grows so steeply over distance that this difference stops being a rounding error and becomes a weapon. The pull on the part of you closest to it becomes wildly stronger than the pull on the part farthest away. Your feet, if you fell in feet first, would be yanked harder than your head, and not by a little. And the closer you got, the more violent that gap would become. Scientists have a name for what happens next, and it is almost too vivid to be real. They call it spaghettification. The gravity difference stretches anything falling in, a planet, a person, a star, into a long, thin strand, like pulling taffy, while crushing it inward from the sides at the same time. You would not be crushed into a ball. You would be drawn out into a thread thousands of kilometers long, atom by atom. It is the single most extreme thing matter can experience, and still, for a few moments, exist. And here is what makes it stranger, and what almost nobody expects. The size of the black hole completely flips the experience. For a small, stellar mass black hole, the gravity changes so sharply over a short distance that you would be torn apart while still far outside it, before you ever reached the edge. But for a truly enormous one, the change is so gradual that you could cross the point of no return and feel nothing at all, calm, intact, unaware, and only be stretched apart much later, deep inside. The bigger the monster, the gentler the trap. That detail matters more than it seems right now. Keep it. But being stretched is not even the part that breaks the human mind. The part that breaks the human mind is what happens to time. The closer you get to a black hole, the slower time runs for you compared to everyone else. This is not science fiction, and it is not a theory waiting to be proven. It is measured. It is confirmed every single day, because it is the exact same effect that forces the clocks on GPS satellites to be corrected continuously. Without that correction, the navigation in your phone would drift wrong within hours. Near a black hole, that subtle effect becomes monstrous. If you fell toward one while someone watched from a safe distance, they would see your clock slow, and slow, and slow, until, at the edge, you appeared to freeze in place, hanging there, forever, fading but never quite crossing. And from your side, you would look back out at the universe and watch it speed up. You would see stars age. You would see the future of everything you left behind play out in fast forward, compressed into the final seconds of your fall. You would, in a real and literal sense, watch the rest of time happen. Remember that. The idea that the edge is where time itself comes apart, because it pays off at the very end of this video. Now, before you ever reached that edge, there is something that would have killed you long before gravity or time ever got the chance. And it is the thing that actually makes black holes deadly across distances so vast they are hard to picture. When a black hole is feeding, pulling in gas, dust, and the shredded remains of stars that wandered too close, that material does not drop straight in. It spirals, the way water circles a drain, forming a flat, glowing disk that whirls around the black hole at a sizable fraction of the speed of light. The friction and compression in that disk heat it to temperatures that climb into the millions of degrees, far hotter than the surface of the sun itself. A feeding black hole is not dark at all. It is wrapped in one of the brightest, most violent objects in the entire universe, screaming out radiation and jets of particles that would sterilize a planet long, long before that planet ever drifted close enough to fall in. This is the cruel irony at the heart of the whole thing. The black hole itself is invisible, the darkest object that exists, but its dinner table is a furnace you could see from clear across the galaxy. Distance from a black hole does not protect you the way distance from a fire does. Its light reaches out to do harm where its gravity never could. And at the very center of that furnace sits the line that gives the black hole its name, the point of no return. It is called the event horizon, and the strangest thing about it is that it is not a thing at all. There is no wall there, no surface, nothing you could touch or see. It is simply a distance, the distance at which gravity becomes so strong that to escape, you would need to travel faster than light. And nothing in the universe can travel faster than light. So nothing escapes. Not a spaceship at full power, not a radio signal, not a single particle, not light itself. Cross that line, and you do not just leave the universe behind. You leave the part of reality that the rest of us are even able to ask questions about. From the outside, we can never again receive a single bit of information about you. Everything that has ever fallen through an event horizon is still in there, in some sense we genuinely do not have the language for. Which raises the only question that matters. What is actually inside? And this is where the most honest answer in all of science is also the most unsettling. We do not know, and it may be that we cannot know. Our best theories, the same equations that have never once failed us anywhere else in the cosmos, say that at the very center, all of that mass is crushed into a single point of infinite density, a place called a singularity. And at that point, the rules of physics, the rules that describe everything else in existence, simply stop working. We have not figured it out yet. They break. The math returns infinity, which is the universe's way of telling a scientist the question itself has fallen apart. It is the one place in all of reality where our understanding hits a wall and goes completely silent. And because nothing can carry information back out across the event horizon, we have no way, not now, not ever, not even in principle, to send something in and have it report back. The center of a black hole may be the single greatest mystery that exists, and it may be permanently sealed from us by the laws of nature themselves. And yet, even these objects, the ones that seem to break every rule and outlast everything, may not last forever. That is perhaps the most surprising fact of all. Decades ago, physicist Stephen Hawking showed that black holes are not perfectly black. Through a subtle quirk of quantum physics at the very edge of the event horizon, they leak the faintest possible trickle of radiation. And that means they slowly lose mass. Given enough time, a black hole evaporates. It dies. Now, enough time here is a number so large it makes the current age of the universe look like a single heartbeat. A black hole, the mass of the sun, would take vastly longer than the universe has existed to fade away. But the principle reorders everything. These are not eternal monsters. They are the longest-lived things in creation, and even they are on a clock. The universe, given long enough, erases even its black holes. So now you understand what happens near a black hole, in order: the violent birth, the dark, the cold, the stretching, the bending of time, the furnace of radiation, the line you cannot uncross, the silence at the center, and the impossibly slow death. Which brings us all the way back to the question we started with. Could Earth survive being near a black hole? And to answer it honestly, I have to tell you something I have been holding back this entire video. Earth is near a black hole. Right now. It always has been. 26,000 light-years from where you are sitting, at the dead center of our galaxy, there is a black hole with the mass of about 4 million suns. Its name is Sagittarius A star, and every single thing in the Milky Way, every star you have ever seen with your own eyes, the sun, this planet, your house, you, is orbiting it. We are circling a supermassive black hole at roughly 500,000 miles an hour, and we have been doing it for the entire history of life on Earth. for every sunrise that has ever happened, without anyone feeling a thing. The monster was never coming for us. We have been living right beside it, calmly, the whole time, and out there in other galaxies sit the true titans, objects like TON 618, somewhere between 40 and 60 billion times the mass of the Sun, so large that astronomers still argue over which one truly holds the record. We fear ours. Ours is a pebble next to those. And here is the turn that changes the meaning of everything you just heard. That black hole at the center of our galaxy is not the thing that would destroy us. It is one of the things that holds us together. Its gravity is part of the anchor that keeps the Milky Way from flying apart, that keeps the hundreds of billions of stars moving in their lanes, that keeps the whole vast spinning structure we live inside from simply unraveling into the dark. The object we are taught to picture as the ultimate destroyer is, at the scale of a galaxy, closer to a keystone. Pull it out, and it is not clear there is a galaxy left at all. Remember the question, what happens to Earth near a black hole? The frightening answer was never the real one. The real answer is the quiet one. Near a black hole is exactly where Earth has always been. It is the reason there is a galaxy here in the first place, with a steady sun, on a quiet arm, far from the chaos of the core. A place calm enough and stable enough for a planet to hold its oceans for 4 billion years, long enough for something on its surface to wake up and look toward the center and ask what that thing is. The object we fear most in the universe is, from far enough away, the thing keeping the lights on. And that leaves one last thought to sit with. We spend so much of our imagination picturing the cosmos as a place that is trying to kill us. And maybe the truth is stranger and better than the fear. Maybe the most dangerous objects in all of existence are also, at the right distance, the ones we quietly owe everything to. Up close, a black hole is the end of physics. From far away, it is the center we orbit, the anchor we depend on, the reason the night sky holds still enough to be beautiful. The only thing that separates the two, the destroyer and the keystone, turns out to be nothing more dramatic than distance, which makes you wonder how many other things out there, the ones that look like monsters when you get close, are quietly holding something together from far away. If that just rewired how you picture a black hole, you already know what the like button is for. And if you want to keep falling, the full journey to the center of one is waiting on the channel.